Integration of the reciprocal function. Recall that the first derivative with respect to x of ln x is equal to 1 over x where x is greater than 0. Reversing that, the indefinite integral of 1 over x dx is equal to ln x plus c where x is greater than 0 and c is the constant of integration. Now in this instance, we're specifying the right-hand branch of the hyperbola where x is greater than 0. But what if x is less than 0? It is possible to integrate in the left-hand branch of the hyperbola. Consider the first derivative of ln of negative x. Now, d dx of ln of negative x is equal to negative 1 over negative x. Of course, the negatives cancel, and that gives us 1 over x. So in both of these situations, first derivative of ln of x and the first derivative of ln of negative x both result in 1 over x. Now in this instance, where x is less than 0, the indefinite integral of 1 over x dx is equal to ln of negative x plus c, where x is less than 0 and c is the constant of integration. So depending on the situation and depending on which branch of the hyperbola we're dealing with, x is either greater than 0 or less than 0, or we're dealing with ln of x or ln of negative x. But what if the branch of the hyperbola is not given? The indefinite integral of 1 over x dx is equal to ln of the absolute value of x plus the constant of integration c. And in this case, that covers both branches of the hyperbola. Recall that integration across the vertical asymptote is undefined. For example, the definite integral of 1 over x dx from x equals negative 1 to x equals 1 is undefined because the integral crosses the vertical asymptote at x equals 0. Recall that the first derivative of ln of f of x is equal to f dash of x over f of x by application of the chain rule. So the numerator is the first derivative of the denominator. Reversing the chain rule, the indefinite integral of f dash of x over f of x dx is equal to ln of the absolute value of f of x plus the constant of integration c. So whenever we have a situation where we have a fraction where the numerator is the first derivative of the denominator, the primitive function will involve a logarithm, and what's inside the logarithm is the denominator itself, which is f of x. So for example, the indefinite integral of 2x over x squared plus 1 dx, note we have a fraction where the numerator is the first derivative of the denominator. The primitive function will be ln of the absolute value of x squared plus 1 plus the constant of integration c. Example 1a. Find the indefinite integral of 3 over x dx. Now 3 is a multiplying factor which can be taken outside the integral. So the integral can be rewritten as 3 times the integral of 1 over x dx. And that equals 3 times ln of absolute value of x plus c. Example 1b. Find the indefinite integral of x over x plus 1 dx. Now the numerator will need to be modified slightly. So we can rewrite the numerator as x plus 1 minus 1. So notice that the value of the numerator technically has not changed. However, we can then turn the integrand into a form that is integrable. So the integral of x over x plus 1 dx is equal to the integral of x plus 1 minus 1 over x plus 1 dx. We could rewrite this single integral as a difference of two integrals. So that equals the integral of x plus 1 over x plus 1. So I'm just going to cut the fraction here, minus the integral of 1 over x plus 1 dx. Now x plus 1 over x plus 1 is just 1. Hence we have the integral of dx here, or the integral of 1 dx. And this integral here, the numerator is a derivative of the denominator. So we have the integral of dx minus the integral of 1 over x plus 1 dx. And the integral of dx is equal to x, and the integral of 1 over x plus 1 dx is equal to ln of the absolute value of x plus 1. So the integral of x over x plus 1 dx is equal to x minus ln of the absolute value of x plus 1 plus the constant of integration c. Example 2a. Find the first derivative with respect to x of x ln x. Now we have a product of two functions, so we're going to apply the product rule. This is our u, this is our v. And by the product rule, y dash is equal to u dash v plus uv dash. So in this case, y dash is equal to ln x, so that's u dash v plus x times 1 over x. So that's u v dash. Now x times 1 over x is equal to 1, hence y dash is equal to ln x plus 1, which takes us to part B. Hence find the indefinite integral of ln x dx. Now from part A, the first derivative with respect to x of x ln x is equal to ln x plus 1. Rearranging this equation to make ln x the subject of the formula, we have ln x is equal to the first derivative with respect to x of x ln x minus 1. Next, we take the integral with respect to x of both sides of the equation. So the integral of ln x dx, which is what we're trying to find, is equal to the integral of d dx of x ln x minus 1 dx. Now from the right hand side, the integral of the derivative, these two operations cancel, so we're left with x ln x, and the integral of 1 with respect to x is just x. So the integral of ln x dx is equal to x ln x minus x plus the constant of integration c, and if you're liking, factorize out x, that equals x outside of ln x minus 1 plus the constant of integration c. Example 3. Find the definite integral of x over 9 minus x squared dx from x equals 4 to x equals 5. Now the first point to note is the integrand is a fraction where the numerator and the denominator are both functions of x. Also note that the derivative of the denominator is negative 2x, and we have a multiple of that in the numerator. So it's easy to change the numerator such that the numerator becomes the first derivative of the denominator. So we're going to multiply the numerator by negative 2 such that the numerator is the first derivative of the denominator, but we're going to compensate for that by multiplying the entire integral by negative half on the outside. And that's the general rule with integration. Whatever is done on the inside needs to be compensated for on the outside of the integral. So the definite integral of x over 9 minus x squared dx from x equals 4 to x equals 5 is equal to negative half multiplied by the definite integral of negative 2x over 9 minus x squared dx from x equals 4 to x equals 5. Now the integrand is in the form f dash of x over f of x. So integrating this, we get negative half outside of ln of 9 minus x squared, and of course that needs to be in absolute values, from x equals 4 to x equals 5. Applying the limits of integration, that equals negative half multiplied by ln of negative 16 minus ln of negative 7. And simplifying this expression, that equals negative half multiplied by ln of 2 to the power of 4 minus ln of 7. And applying one of the log laws, that equals negative 2 ln of 2 plus half ln of 7.